name concept from lattice energy. Over here, we are going to talk about Born-Haber cycle for magnesium chloride. Okay, so for this over here, to get magnesium chloride, we need magnesium solid and chlorine gas, right? So atomization in the sense, what is it? The states in the solid to gaseous state, it has to change. If it is if it is a liquid to gas again, so somehow it has to come to gaseous state, or if it is a molecule, it has to become an atom. You have to show it as an atom, that is atomization. So atomization of magnesium, first thing, okay. Then touch the chlorine. So just magnesium alone, atomization of magnesium. Okay. So atomization of magnesium in the sense solid state, because it's a metal. So now it becomes gaseous state. Yeah. So there is no change in chlorine. Again, I'm telling you. First ionization. Then what is the step two? First ionization. So that means the magnesium, which is in gaseous state, becomes magnesium ion. That means that loses one electron. Magnesium, since it is group 2 element, can donate 2 electrons. So first, when it donates one electron, it becomes magnesium ion. And enthalpy change of second ionization, right? Enthalpy change of atomization leads to gaseous state, and enthalpy change of first ionization leads to Mg plus, and enthalpy change of second ionization leads to Mg2 plus gaseous state, right? And till this chlorine untouched, nothing happened. But over here, atomization of chlorine. Okay, and how many chlorines are there? Two chlorine, Cl2, two chlorine atoms are there. So two enthalpy change of atomization. Is that clear? So now chlorine, the atomization leads to this, it's already gas, so we no need to change into gas. But still, what has done here? So it become an atom, molecule becomes an atom over here, right? Yeah. So till this, that means atomization of magnesium, first and second ionization of magnesium, atomization of chlorine. Till this, everything, what is it? Endothermic reaction. That is why arrow moving upward. Got it? So now, if you see the next one, over here, ionization of chlorine. So ionization of chlorine, only one, sorry, there is no ionization, electron affinity, because it is gains electron, right? So chloride, chlorine, two chlorine atoms are here. So it gains two electrons, right? So two chlorines gains two electrons, so that each chlorine will get one electron. So 2Cl minus, okay. What is it? Electron affinity. Enthalpy change of electron affinity 1. Because only 1 will happen here, right? If it is oxygen, electron affinity 2 also will happen. But with chlorine, it is the 7th group element, so it needs only 1 electron. So 2 enthalpy change of electron affinity 1, since it is 2 chlorine. So what is it? Mg2 plus 2Cl minus, both are in gaseous state. Now arrow downwards. So what is it? Exothermic reaction. Now enthalpy change of lattice is magnesium chloride. You'll get magnesium when two gaseous ions react together. You'll get magnesium chloride. And over here, enthalpy change of formation is given when when solid metal, I mean magnesium, reacts with chlorine gas, you get MgCl2 in the sense, that is enthalpy change of formation. This is enthalpy change of lattice. Okay, let's see how to calculate the lattice energy. Yeah, that is more important actually. Yes, listen here. Over here, the magnesium ion in Mg2 plus. So the first and second ionization energies need to be taken into account. So what I am suggesting you, before writing these data will be there in the question, okay? Because you can't by heart, or you can't guess the kilojoules, but these data will be there in the question. So from the question you have to extract the data and you have to calculate it. So what I'm suggesting you, first write the, because what we have seen in the Born-Haber cycle, atomization of magnesium first, right? So atomization of magnesium, how much energy? Plus 1 4, because it is endothermic, right? So positive, positive 148 kilojoules per mole, right? So the atomization first you write. Second, ionization of that too. What is it? First ionization of magnesium. So how much energy? Positive, again endothermic. So 736 kilojoules per mole it takes. And then for second ionization it needs positive 1450 kilojoules per mole. So 3. Now what is the next one? What we have seen? Atomization of chlorine. So atomization of chlorine, again 2Cl, right? Since it is 2Cl, for 1Cl, 122 is the 122 kilojoules is the energy. But over here, two chlorines, right? So 2 into, if it is 3 or 4, then you have to write according to that. Yeah. So 2 into positive 122, because again it is endothermic. Till this it is endothermic reaction. Now electron affinity. Over here it is what? Exothermic reaction. So what is the value? Minus 348. So 2 into minus 348 leads to minus 698. Got it? Then after that, yeah. So now come to the formula. And yeah, one more thing, formation also we have seen in the graph, right? In the Born-Haber cycle, formation is 641 kilojoules per mole, right? And the lattice energy only we are going to find. So, did you understand? All the datas will be there in the question. So, formation they have given, atomization given, ionization, second ionization, atomization of this, electron affinity of this, everything given. So, we have to find only what? This alone we have to find, right? Okay, and that is also exothermic, we know, because the arrow downwards, right? So, we have to find the value. Yes. So what is the formula? See, lattice is equal to enthalpy change of lattice is equal to formation. I'll increase the, yeah. Can you see now? So formation minus over here, what is it? Formation minus, you have to calculate H1. So what is H1 here? The H1 is magnesium, I mean atomization of magnesium, ionization of magnesium, second ionization of magnesium, atomization of chlorine, electron affinity of chlorine. Everything you have to add. Okay. But while adding, keep that in mind. Wherever you have to multiply into 2, that you have to remember. And also the minus symbol. Okay. Carefully you have to do. Otherwise, in the symbols only you will make, in the signs only you will make mistake. Otherwise, other than that, everything will be easy. The minor errors will come only in this calculation. Okay. Be careful while doing that. So lattice is equal to, what is that formation? What is the value we got here? Minus 641. So minus 641. So what is it? I mean atomization of magnesium. Our for that we have seen atomization. What we have seen? Yeah, 148. So 148. Ionization. First ionization 738. Then second ionization 1450 positive, done. And over here what is it? Atomization of chlorine, 2 chlorine, so 2 into 122, and now 2 into minus 348, right? Which is electron affinity. Yes, that. So formation we have written here. So formation minus H1, right? So formation 61 minus 641 minus this, by adding all these, the sum of these will give you positive 1882. By subtracting this, you will get minus 2523, negative sign. That negative sign shows it is exothermic, arrow towards downwards, right? Exothermic, kilojoules per mole. Got it? Hope you understand this von Haber cycle. If you have any doubt, let me know, or if you want me to do any other question, let me know. I'll do it for you. Thanks for watching till then. Bye bye.